Hi guys. So for our lesson today, you are going to need your note packet open to page number 10. You are also going to want to have a calculator as well as your reference tables. Again, I'm just going to show you where a few things are in your reference tables, but it's sometimes helpful to be able to kind of follow along and flip through the pages with me. So for today, the first thing we're going to be talking about is another type of calculation that we're going to be doing, which is called a heat of fusion calculation. Now remember, in this unit, when we use that word fusion, we mean melting, okay? So the heat of fusion, the symbol of which is a capital H with a lowercase f subscripted after it. So we sometimes will read this symbol as H sub f is the way that we say that. So H sub f is the heat that is absorbed by 1 gram of a solid substance as it melts to a liquid at a constant temperature. So it's the amount of heat, if we're talking about water, ice, it's the amount of heat needed to melt 1 gram of ice. Now remember, if we think back to our heating and cooling curves, during the phase change itself, while something is actually melting, it's not changing temperature. Melting happens at exactly 0 degrees Celsius. Once all of it's melted, then you can heat up your liquid. And the flip side of that is true. Once all of it freezes, you can cool down your solid, but the phase change itself happens at exactly 0 degrees Celsius. So the amount of heat that is absorbed in order to melt will be exactly equal to the amount of heat that is released when something then freezes, right? Because freezing is an endothermic process. You have to lose energy to freeze. Melting is exothermic. I said that backwards, sorry. Melting, you are going from a solid to a liquid. That is endothermic because you have to absorb heat in order to melt. Yes. Freezing, you are slowing your particles down to get from liquid to solid. So that is, you have to lose energy. So that is exothermic. Maybe I did say that right. Anyway, you know what I mean. All right. Now, the heat of fusion for water is a constant 334 joules per gram. And you don't have to have this value memorized. This can be found right on the front of our reference table. If I head back to the front page here, table B, you will see heat of fusion, 334 joules per gram. And this is physical constants for water. Now our formula that we're going to use for our heat of fusion is on the back of our reference table in this heat section. It's this middle guy right here where it says Q equals M, which is mass, times H sub F, which we know when we're talking about water is a constant 334 joules per gram. So take a look at practice problem number 1. They ask, how many grams of ice at 0 degrees will melt if 2,250 joules of heat are added? So I always want to start with my formula, right? Q equals mass times H sub F. So there's my formula. My next step would be to substitute in. So I have 2,250 joules as my heat, right? My Q. I am solving for mass. My heat of fusion is a constant 334 joules per gram. So to get M by itself, I am going to divide 2,250 joules divided by 334 joules per gram to get an answer of 6.74 grams. That's how much ice can actually melt. Okay? Easy enough, right? So here's what I would like you to do. I'm going to pause the video. I would like you to try practice problem number 2 on your own. You're going to plug your final answer in, and then we will go from there. All right, I will see you in a minute. Bye. Okay, and we're back. So your final answer here, Q should be equal to 3,340 joules. There you go. So this is the formula, Q equals MH sub F. This formula is what we use anytime we are melting or freezing. Melting or freezing, melting or freezing. That's when we use heat of fusion. Heat of vaporization is anytime we are boiling or condensing. So heat of vaporization, which is H sub V or H vap, however you want to say it, is the amount of heat necessary to vaporize or boil 1 gram of a given liquid. This is exactly the same as the quantity of heat that would be released when the vapor or gas then condenses again. Our heat of vaporization is a constant 2,260 joules per gram. Again, you can find that right on the front of our reference table right here, heat of vaporization. The formula that we're going to be using when we are boiling or condensing is this bottom one right here, Q equals MH sub V. So take a look at practice problem number 1. They ask how much heat is absorbed, so we're solving for Q, when 24.8 grams of H2O liquid at 100 degrees Celsius and 101.3 kPa is converted to steam at 100 degrees Celsius. They give you a lot of extra information in this problem. They're giving you a temperature, they're giving you a pressure. None of that matters. What matters is the fact they're saying converted to steam. Converted to steam means boiling, right? So this is a Q equals mH sub V problem. So I'm going to start with my formula. Q equals mass H sub V. Okay. I'm solving for Q. My mass is 24.8 grams. H sub V is a constant, 2,260 joules per gram. So do the math on this, multiply those together, round 3 sig figs. I get an answer of 56,000. So without rounding, let's just talk about rounding for a minute. I get this as an answer, okay? 56,048 joules. Now, technically, I need to round this so it has three significant figures. But if I try and round this to 56,000, that only has 2. But if I try and round it to 56,005, that has 4. So the answer here of what to do is you can always put stuff in scientific notation. And then you can cut it to wherever you need to cut it in order to get the appropriate number of sig figs. Okay. Again, guys, I'm going to pause the video. I would like you to take a look at practice problem number 2. I'm going to have you type in your answer, and then we'll reconvene. See you in a minute. Hi, welcome back. So our answer here, 144,000 joules. Again, I rounded that to match the 3 significant figures that were in the mass. Okay. When do we use this formula? Q equals mH sub V. We use this formula anytime we are boiling or condensing. So to summarize, we have 3 different formulas that we have talked about. The heating cooling formula, MCAT, Q equals MC delta T. This is the formula that we use when there is a temperature change. You are heating up or cooling down within a single phase. You're heating up a liquid, you're cooling down a solid, you're heating up a gas, whatever it might be. You do not use this formula when there is a phase change like boiling or melting or freezing or condensing. When we're melting or freezing, that's when we use Q equals mH sub F, heat of fusion. That's when you're going from a liquid to a solid or a solid to a liquid. When you are boiling or condensing, we use Q equals mH sub V, where HV is a constant, 2,260 joules per gram, liquid to gas, gas to liquid, okay? So